Hello everyone, we are from Anuradha Engineering College, Sikkim, Department of Information Technology. Our project topic is image steganography using DCT and IWT and guided by Ms. Sarita Savali. My name is Devika Madhusudan Gaikwad.
My name is Anju Shivlal Sharma.
My name is Rachna Namdev Khadse.
My name is Shweta Jain Patil. I am here to present PowerPoint presentation. In this, contents are Introduction, Image Steganography, System Architecture, Flow of Execution Sender Side, Flow of Execution Receiver Side, Implementation and Testing, DCT Algorithm, IWT Algorithm Embedding Process, IWT Algorithm Extraction Process, PSNR, Future Scope, Conclusion, References. Introduction. In introduction, there is a large development in the communication field recently. Hence, the protection and confidentiality of information has become very important need for communication. This requirement can be achieved by various methods such as steganography and cryptography. Coverage data can be text, images that hide information such as text and images. Hiding data, taking the object of cover image is referred to as image steganography. In digital steganography, images are widely used as cover object because of binary representation of pixel intensity whose excess bits are used to hide information. Image steganography is the technique of a data hiding behind the cover image is the pixel intensities are converted into binary representation to hide information is most redundant bit. This is one of the example of image steganography in which confidential information is embedded in cover image which gives us stego image. System architecture. This is the figure of system architecture that is implemented. The modules of this steganographic tool are also included in architecture. The user can be either the sender or the receiver. On the sender side, an user selects the plain image which gets converted or divided into a pixel by pixel as this algorithm works on pixel. Then encrypt it by cover image by embedding the secret message in it. Then we get stego image. This process gets reversed as we take this stego image from user to retrieve the original message by decryption method and gets again converted in the pixel. And finally we get our original image, that is plain image. Execution on sender side. Figure shows the flowchart with the encryption part of the tool. We take a secret image as input. At first, the secret image is converted to a text file using base64 conversion. Then the generated text file is encrypted with a password-based encryption algorithm to generate an encrypted text file called ciphertext. Using a customized embedding algorithm, ciphertext is embedded onto a cover image. The output is the stegography, that is a cover image with a secret message embedded in it. Flow of execution on a receiver side. Next figure shows a flow chart with a decryption part of a project. To read the hidden message, that is secret message, the stegography has to be decrypted. So the stegography is used as input to the retrieving algorithm. If the retrieving algorithm is not the same as the embedding algorithm, there is no way that the correct output can be obtained. The correct output from a retrieving algorithm is the ciphertext is used as input to decryption algorithm. This decryption algorithm is the same as the encryption algorithm. Otherwise, the secret message cannot be determined. And also, the decryption algorithm takes a key password to generate plain text using base64 conversion, implementation and testing. DCT, that is discrete cosine transform algorithm, is most popular technique for image compression used over the past several years. JPEG is the one of major reason of popularity. In this, it is used by many non-analytical applications such as image processing and digital signal processing applications. For example, video conferencing. It is an orthogonal transform which has fixed set of functions and it is used to map an image space into frequency. advantages of DCT are ability to pack energy in the lower frequencies for image data, and second advantage is it has ability to reduce the blocking artifact effect, and this effect results from the boundaries between sub-images become visible. DCT process pattern. This section represents JPG compression steps and RGB to YCBCR color space conversion. Original image is divided into 8 by 8. The pixel values within each block is shifted from 0 to 255 to -128 to 127. The DCT works from left to right, top to bottom, thereby it is applied to each block. Each block is compressed through quantization. Quantized matrix is entropy encoded. Compressed image is reconstructed through reverse process. This process uses inverse discrete cosine transform. The first stage in the compression is the transform. This stage is necessary to convert the image data from spatial domain into frequency domains. Hence, YCBCR converted to RGB. This is IWT algorithm embedding process. We will see the following steps in flowchart. The embedding process refers to the hiding of the secret information in the cover image and the steps that precede it for the preparation of the cover image. Embedding process is depicted in the figure. The flowchart for the embedding algorithm is: firstly, read the cover image, split it into blocks. In this, the block size can be 8 by 8, 16 by 16, 13 into 13, 64 into 64, 128 into 128, or 512 into 512. Transform each block using IWT. Prepare the keys from random traversing. The keys are the random patterns according to which the blocks are transversed, and also the random order in which the blocks are selected. For adaptive embedding, run the analysis to determine the number of bits for each coefficient. Read secret message or information in binary. Traverse the blocks according to the keys and insert the information adaptively or non-adaptively as the case may be. Once all the information has been inserted by LSB substitution, perform inverse IWT on each block to transform the image back to spatial domain. The image now carries the secret information hidden safely inside and can be used for transmission or the other purpose. This image is called stego image. This is IWT algorithm extraction process. We will see the following steps in the flowchart. The process to extract the data is almost the same as that of for embedding. Extraction is depicted in figure. The steps followed in the extraction process are: the flowchart for the extraction algorithm is: read the stego image, split it into blocks. The block size can be any of 8 by 8, 16 into 16, 32 into 32, 64 into 64, 128 into 128, 256 into 256, 512 into 512. Transform each block using IWT. It is assumed that the keys that are used to determine the traversing pattern are available with the receiver. Traverse the blocks using the keys. L is fixed if it is not adaptive. Adaptive L is obtained through the equation 4,13 or 4,14. Extract L bits from the coefficient. PSNR ratio. The PSNR block computes the peak signal to noise ratio in decibels between two images. This ratio is used to as a quality measurement between the original and a compressed image. The higher the PSNR, the better the quality of the compressed or reconstructed image. The mean square error and the peak signal to noise ratio are used to compare image compression quality. To compute the PSNR, the block first calculate the mean squared error using the following equation, and this is the formula for MSE. In the previous equation, M and N are the number of rows and columns in the input images. Then block computes the PSNR using following equation. This is the formula for the PSNR. Future scope. In today's world, we frequently listen a popular term hacking. Hacking is nothing but an illegal access of a data which can be collected at a time of data transmission. With respect to steganography, this problem is frequently taken as a steganalysis. Steganalysis is a process in which a steganalizer crashes the cover object to get hidden data. So, whatever be the technique will be established in a future, degree of a security related with that has to be kept in mind. It is hoped that the dual steganography along with the cryptography may be some of the future result for this above mentioned problem. Conclusion. In this way, the PSNR shows the quality of image after hiding the data. From the results, it is clear that the PSNR of DCT is high as compared to the other two techniques. This implies DCT provides the best quality of the image. An embedding algorithm is said to robust if the embedded message can be extracted from the image has been manipulated without being destroyed. DWT is highly robust method in which the image is not destroyed on extracting the message hidden in it and produce maximum security. These are the references. These are the certificates for the courses and a quiz that are acquired by the group members. Thank you.
This is our project demonstration of image steganography using DCT and IWT. We implemented the process of integer wavelet transform, that is IWT, and discrete cosine transform, that is DCT, and finally the difference between two in PSNR, that is peak signal to noise ratio value.
So first, we will see the steganography using discrete cosine transform. Here, first we will take an input image. And now we will select a message image. Now here in DCT, in embedding process, the embed message is a third message where this original image and message image is combined, so that the quality of our original image and message image will be as it is, and the message image will not get decrypted by the third party. Here we will embed the message, and for embedding we will use another image. So in this image, these two images are embedded. Also here we get the PSNR value. In DCT, when signal is discrete, PSNR ratio is calculated when message is embedded and not calculated when message is extracted. This is because pixel get distracted with respect to the PSNR ratio. We will get the PSNR ratio quite less here. Now we will extract the image, and after extracting we will get our extracted message. So this is our steganography using discrete cosine transform. Now we will see the steganography using integer wavelet transform, that is IWT. In IWT, we are taking one image. Here we need to take image in color pattern only, because we are having one function, that is RGB to gray, where our image is converted into gray image, and that gray image get divided in a wavelet patterns. So first we will embed message. For this we will take an input image. Here we will take, if we take a black and white image, it will give an error. Please select the color image. So we will select the color image. Here histogram means
it is converting an image from RGB to grayscale. Now, this is integer wavelet transform. In integer wavelet transform, pixels are divided into different wavelet patterns, and here transformation is completed. Whenever this image is in wavelet transform, we need to generate a secret key. This is the security which IWT provides. Here we allow the system to generate the secret key. Here secret key is generated. Now we will go for the process of embedding. This is the wavelet transform pattern, and in this we are embedding the message. Here embedding process is done, and after that we are doing transformation. First we did wavelet transformation, and now we are doing inverse transformation. Now here secret message is embedded in an image. Now we will validate the part. We get the PSNR ratio. Here we got the PSNR value after embedding process. Here hiding process is done. Now this is the process of extraction. During extraction process, this is the image we get for the extraction. Now we will do the transformation. Next, we will go for the extraction. When we embedded the message, we got an image with the secret data, with a secret message. This secret message is recalled here, and extraction process is completed. Here, secret data is obtained. Now here, we get our secret message as an output. Thank you.